you tell us a little bit about your company and what it does?
Sure. So I'm Mathieu Duperré. I'm the CEO and founder of Edgegap. I founded Edgegap in 2018. We're a software company based out of Montreal, Canada, and we've built a platform to allow developers, and mainly game developers, video game developers, but any developers to leverage edge computing in a very easy and easy way, if you will.
So one of edge computing's core promises is to bring data processing closer to the user for improved latency, among other things. Why don't you tell us about latency in gaming and why technologies such as CDNs haven't completely solved the latency challenge?
Sure. So CDN is a one-way street, right? So you're retrieving static content, right? So think of Netflix, for example, where you're being served a video which was already made before. Video games, among other use cases, is one that calls for a dynamic interaction with a third-party element. So think of it, if you take any kind of multiplayer game, they're going to use a game servers, and think of a game server as a referee in a soccer game or a football game for a European. So the game servers is there to be the man in the middle, to decide what really happens, and it does. In some cases, it even go as far as reproducing the whole physics and making sure that the 3D was not messed with from any player side. Latency comes into play in different shapes for the gaming industry. If we're going to talk about network latency in a minute, but there are really four types of lag for gamers. The first one is the human delay, right? Lag is the time it takes for between an action and what's happening on the screen, for example. And the main cause for lag is the human reaction time. Olympic athletes typically take an average 80 milliseconds of reaction time to start running when there's a new race. Pro esports athletes, so these people playing video games professionally, typically have an average of 110, 120 milliseconds of reaction time. So I'll let you guess that typical players will have a fairly high amount of reaction times in terms of latency. Now, that lag is the fun you have in a video game. So we don't necessarily want to, it's impossible to remove that. So the three other ways that you have lag in a video game is network latency, which we'll talk about, and the two other sources of lags are the devices that are being used, whether it's on the server side or on the end user side. Look at what kind of smartphone they use, the Xbox, the PCs, and what's not. And the last but not least will be the code itself, like the game code or the application code, which can induce lag. But the one we'll talk about is network latency. That's the second worst offender after the human behaviors. And human, as we said, is the fun you want to have. So you really can't get rid of that. So speaking of network latency, we just released an hour ago, literally, a survey we've done with 2,000 players around the world, in the US and the UK, sorry, not around the world. So these are hardcore players. Not only lag is the number one problem, but a third of those players said that they were stop playing a game if there's too much latency or lag in a given game. So that means that from a studio's perspective, they lose close to a third of their revenue. 34% of their revenue is lost just because they have latency in their game. When I launched Edgegap in 2018, I saw edge computing, aka distributed environment, as a way to mitigate that problem. And the way we're doing it is by using that distributed infrastructure in different ways than what's being done today with the centralized cloud providers, for example. And the analogy I always give is if latency is the time it takes for you to drive from your house to your office downtown, existing solutions on the market were always around trying to build a highway just for you, give you a faster car, or build a lane dedicated for you, whereas the solution is it's a physical problem. The real solution is to take the office and move it next to your house so you don't have to drive on that highway and go downtown.
Work from home.
Yeah, well, kinda, right? Kinda. But you still need, assuming you still need to interact physically with other people.
So, why have game developers had challenges in leverage edge computing platforms?
That's a good question. They're used to they're used to the cloud markets, right? The cloud markets is a market where these are the tools that we've built as a cloud provider. For example, not Edgegap, but if you take Amazon or Google or Azure, they've built tools and they're giving you tools, and you need to figure out what you want to build with those tools. So you need human power, you need resources to build and manage those tools that are building something. And those tools are made for a centralized environment, right? So studios are using what we call fleets. So they're fleets of game servers that are managed by tools which are fairly slow because they never had to be quick in the first place. And those tools are starting fleets of servers which are waiting and standing by for players to connect. What that means is, if you're making a football game and you expect 100,000 players every day, you're gonna start a few thousand servers just waiting and standing by so that when the players connect and open up their PlayStation or their phone, they can connect to that standby servers. And that works for a centralized environment. But if you look at a distributed environment, that doesn't jive. That doesn't work for two reasons. First is there's a cost associated with that, right? If you need to have a few hundreds or even a few thousand servers waiting and standing by in 4 or 5 locations, it may make sense from a cost perspective. But if you look at 100 or even thousands of locations, that's not gonna add up from a cost perspective. And from a tool perspective, then it's also a different story where the tools are made to not be in a rush. And when I say in a rush is they have all the time they need to start servers. They may have like 15 minutes to start a server, prepare everything, make sure that it's ready and to serve players when they come. And when an instance of a server is up and running, then you can send players there. If you look at a distributed environment, you don't have the luxury to do that. You need to do it very, very, very quickly, and you need to have those things up and running in milliseconds, because otherwise you end up with this notion of having 100 servers in thousands of locations, which just defeats the purpose in the first place. And looking at it, the other point was around more of an infrastructure perspective. If you have a limited amount of capacity in those edge locations, are you going to have thousands of game servers from thousands of different games running all at the same time? That's not working. It works for server farms at AWS in Ohio, but if we look further ahead and we think of Edge as a pizza box slap on a telephone post, you won't have that much power. So you need to use that power only when you have people ready and willing and ready to use those capacity.
Well, also, I guess you would say that there wouldn't be that many edge sites that actually had enough resources. And by that extension, we would be working with multiple infrastructure providers at the very least. But moving on, what is some of the challenges your company has faced in building your platform for this problem, and how have you solved those challenges?
Very early in the process, it was, and something that keeps coming up when I attend edge computing events or what's not, is we had to build the edge. So it was a case of initially I said, oh, we're going to build this tool, a policy engine, just to leverage the edge and what's not. But a lot of the ISPs and the providers and private like CDNs and what's not, they were all asking, oh, tell me where you need those edges, or bring me a killer app, and it was well, I need the infrastructure to sell it because it kind of otherwise it's just it's another cloud providers. I had an ISP, which I'm not going to mention the name, but they approached us and they said, "Oh, we want you to do some tests in our lab." And, okay, oh, cool. How many locations? We have one location. Okay, it's one location in the lab, not even accessible on the internet. Is not edge computing. It's a server. It's like it's a normal DC. So very early in the process, like early 2019, I say, we figured out that we were going to have to build our own edge infrastructure. And to do so, we ended up taking what I call the Pokemon approach. So we collected providers as Pokemon cards. We came up with an architecture allowing us to add new providers within minutes, not days, not weeks, not even hours, but within minutes, we're able to add more providers. And we support, so with all of those providers, we ended up, like today we have access to 350 different locations around the world, and we have a few other providers we're looking to add. So as the wireless providers of this world, the CDN, the cloud, there's also a lot of private DC, private edge. As those guys are physically building that infrastructures, we're able to add them to our system and say, okay, now we can deploy more payload in specific regions. But we discovered that pretty early that we were going to have to do it. Otherwise, if we only rely on, especially to hit the gaming market, because we had a lot of ISPs, for example, they were like, hey, we've built the edge, maybe we have 10, 15 locations, and we're going to have 15 locations in 6 months. But it's only in one country. And game studios, they want to sell their games everywhere, right? So that's again, chicken or the egg. We ended up building the chicken so we can get the eggs, if you will, or something like that.
How much did that cost? I don't recall seeing you having raised a lot of external funds to do this, but maybe you want to give us an update on that part.
It's an interesting question, and you're probably going to be surprised about the answer. The fact that we didn't raise a lot probably is what not saved us, but got us to a point where we are today. We've only raised $1 million Canadian dollars, which is like what 20 US dollars. Forgot the exchange rate, but it's horrible. But we didn't raise much for the seed 2 years ago. So that forced us to build a platform and architecture which takes into account those costs, like the cost of running things everywhere. And we had a competitor who, unfortunately for them and the people who were working there, went bankrupt a few months ago because of that. Because they had a lot of money, they didn't care about spending, so their system was heavy, it was expensive. Since we had so little money, and I mean it, we had like most of the furnitures in that back door office was coming from my house. Since we had so little money, we had to build a platform and architecture which would just turn things down when there's no traffic. So it had to be on demand for everything and anything and everywhere, and it was always future thinking about what we're going to do, what we can do, what we want to do, but at the same time being mindful about how much we're spending, because everybody is after you. Everybody is after that money. Everybody wants to charge you an arm and a leg. You need to be mindful about that. So we ended up with a platform which is super lean. It's super lean. We have this. I think that the architect ended up calling it like the building architecture. So we call it level 0, level 1, level 2, as in a skyscraper. And level 0 is one edge location, but there's nothing, there's no cost, because we don't own any hardware, right? We use everybody else's hardware. And we're able to get to that level 0. We're able to say, yep, there's no cost for us there since there's no one paying us for anything. But once we start to see traffic, or once we know that we're going to need a certain amount of traffic, and in Singapore, around Chile, or in some specific regions, the system just wakes things up and scales things up. So we're going to go get level 1, 2, 3, 4 up to like there's level 15 or something. And when you build a new level, which you have new edge and new AP, you're able to deploy applications and new game servers in those locations. But how you do so is also very important, right? Because let's say, assume you have 350 locations. In all of those 350 locations, maybe you have like 4, 5, 10 different bare metal servers or VMs running. Now, you need to be mindful as game servers and applications they come and go too, right? So they're going to come, we're going to start a bunch of servers, we deploy those game servers. Now, as those game servers leave, it leaves also unused capacity that I have to pay, right? So how do we manage those different level of infrastructure for a given edge locations? How do you make sure that you optimize that infrastructure? We have pretty detailed KPI about what we call allocations. So when something is allocated, it means that I'm receiving money for something that I'm paying for, and it's part of why we made it so far, I guess. So controlling the allocations, making sure we know where the money goes and what's needed, where it's needed, and then when we turn things down, because the game cycle, you need to understand something. And pretty much every game out there are like that. The traffic flow for a given day, the traffic pattern will pretty much double to triple over 24 hours. So it's going to go up by 3 folds as people come out of their job, come back from schools, but it's also going to go down in that 24 hours. So you can't just assume that you're always going to have 100% of the capacity, otherwise you're going to go bankrupt pretty quickly. So the system will scale up and will scale down, and will use those resources in a very, very smart manner, so that Matthew is happy at the end of the month when he gets all of those providers' bills, and that number jives at the end.
Well, so going back to gaming, it's obviously a very large and fast-growing industry still. Adding on to the myriad, though, of existing and popular games like Fortnite, Call of Duty, Minecraft, whatnot, there are now a lot more companies talking about Metaverse, Web3, AR, VR, along with gaming. So what opportunities do you see for Edgegap in this coming era of game design? And when do you see those markets developing from what I think now is a lot of hype and into a solid market for your company?
Yeah. To that, let's look at your question from 3 different angles. So you've asked about Metaverse, Web3, and AR, VR, which I think are they're somehow connected, but they're different things. The easiest one would be AR, VR. AR, VR calls for extra low latency, otherwise you end up puking, which is way more frustrating than just losing in a game, right? And we already support that market. We already have a few customers doing those kind of projects on the platform. And at the end of the day, the difference really is around the end user device. So if you're not using a smartphone or an Xbox, you're using a headset. And for us, the results is the same. We're just trying to get the lowest possible latency, and it works, and that's fine. So we're really happy with that. That one is checked. The 2 others, the Metaverse is definitely in the hype train at the moment. Everybody wants to tag along the Metaverse, and we've all seen Ready Player One movie, and we all think we're going to be the next. Forgot the name of the character there, but the truth is, we've had something similar to a Metaverse for years. Those games are called MMO, massively multiplayer online games. From a lot of angles, Metaverse is just about community of people meeting together, whether it's to play or just to interact, to watch arts, something like that. We could technically say that VR chat, for example, is a Metaverse somehow. Roblox or Fortnite can already be seen as Metaverse. Now, from that angle, we're providing a platform and environment for developers to build their own metaverse. We have a customer. It's a company in Sweden called Iberworld, and they're building a platform which is giving the tools for developers, but even for anyone, including my kids, for example, to create those worlds, to build those virtual environments, to have those interactions with other people. The key for us, for Edgegap, the key to be successful in the metaverse industry is the ease of use. So the developers want to have at the heart of their concerns and their interest what they're building, the end users, the players' interest. Are they going to have fun? What's going to be the mechanics behind it? What's going to be the interaction? Is the experience going to be good? How am I going to make money as a developers, right? That's what we want to have on top of their mind. We want them to leave it up to us to manage the automation, the plumbing. So we take care of the plumbing. We take care of managing everything. We take care of taking those apps, those metaverse style apps, and make them in the hands of everyone around the world, regardless of where they are, and provide the same quality of experience to someone who is in LA as someone who is in Cuba or South Africa or Tokyo. Regardless of where you are in the world, you're going to have the same experience, and that's what we strive about. And the studios, developers don't have to worry about, oh yes, I need to understand those 130 products from AWS. No, don't worry about that. We're going to make it easy for you to consume these. Focus on your app, focus on your game, leave it up to us. The last but not least is Web3. Not sure it's worth talking about since what we've seen the last 3 weeks was a big meltdown in the cryptos, and that trickled down in the NFTs and what's not. But we already have some studios making games. We believe in there is something there. There definitely is something there. It's all about finding the right angles, because as with everything, when the hype started with NFTs, we've had a lot of snake oils doing pre-sales, studios or companies doing pre-sales on something which was going to be big, but then you buy a virtual piece of land which can technically be reproduced 100,000 times, but then they're trying to convince you that it's rare because there is something there. Now, what the angle is remains to be seen. What the real angle is remains to be seen. We're allowing those developers to distribute their applications and their payload in more locations than they can chew on. We're allowing them to validate their chains through hundreds of locations, whereas if you go to a public cloud or any hosting providers today, you end up with a handful of locations and you're seen as a centralized token, for example, and stuff like that. So long story short, it's a market which we serve well today, but they need to find that market needs to keep in mind that the player wants to be entertained in the first place. So that's what's missing, or that's what we believe and we see growing at the moment.
Yeah, I think from what it appears, it's a theoretical market for edge computing, because the focus is on running applications in a decentralized fashion. So edge computing is the answer to their problem of how to run the applications. But like you're saying, getting the right application has not happened yet. Well, so I wanted to pivot a little bit because it appears that you added enterprise solutions to the product portfolio recently. Can you tell me a little bit more about what opportunities you see in the enterprise and how you're differentiating from competitors ranging from Cloudflare and Fastly and Ridge and Section.io and others, who are offering edge infrastructure and orchestration solutions?
Yeah, so we've started to be public about that like a few months ago. Most of my my business development sales force is targeted toward the gaming industry today, but we were being asked by non-gaming customers. Every now and then would get people sending us emails, visiting our booth, and asking about our solutions. They were looking for low latency solutions. And what we did is we started to put together projects with a driver, in the sense where if we have a potential customers, then that's enough for us to accelerate maybe some features on the roadmap, maybe spend money on a proof of concept, stuff like that. Whereas if you're just doing something because you think it's going to work, it's a different story. And we started to do that like a year ago. We already have non-gaming customers on the platform. And the goal for us was to at least have those people come on our website and see that, hey, yes, to support non-gaming use cases. That goes from what you've seen on the website, but also in the documentation. When we talk about players, sometimes we're trying to shift away from that and talk about users or devices. We had IoT, for example. We had car parts manufacturers, not car manufacturers, but those building the parts for those cars manufacturers approaching us. We had a slew of other use cases. Company in APJC building robots for remote surgery and stuff like that. As a startup, we have a limited resource, as we discussed earlier. So that's why, unless we have a real potential customers who's looking to drive the needs, then we're kind of going very slowly and tread carefully. And today, the benefits that those customers or those prospects see in us is we already have a worldwide edge. So they can sell their service, their product in a worldwide manner without having to deal with ISPs in the UK, ISPs in the US, ISPs here, there. They can have one throat to choke, come with us, and it's a working scenario. We have a live environment, it's a production environment, and they can get their stuff everywhere without having to select locations, which is the case with most solutions today. Most of the solutions that you mentioned will ask the developers and say, all right, we can help you. We have 50 POPs, but then which one do you want? So here's my server. It's going to be at $5,000 per month, and if you pick 20 locations, then it's 5,000 times 20. That's not going to cut it. That's not going to cut it. That's typically how we get in when they see our commercial model and how we operate. They're typically quite quick at testing it out and going in the platform, because our model is, when you have an application running, then the meter starts, and when that instance stops, then so is the meter. We are seeing a non-negligible growth in the web space. So the web space is evolving. We're seeing more and more server rendering side, and we're working hard at supporting those use cases. And you should hear from us in the next few months about that.